All right, now we're gonna do, oh, give me a second. All right, so we're gonna do 8.3, which is simplifying rational exponents. And we're gonna go through the radical rules. So like like with exponents, there are a few rules that govern powers, products, and quotients. So we already discovered the rule with powers, and we name it the power rule of radicals. So let me write that part. With exponents, there are a few rules. That govern powers, products, and quotients. Okay? We have already discovered the rule with powers. And we name it the power rule of radicals. Now, let's do the first one. This one is called power rule. And it says, we did this one, x, this is equal to, denominator is the index, x of r. And we said that this was the same as to the exponent of r. And we could do that if this part is real. Okay, now let's do the product rule. Oh, product rule. This one is then when we are multiplying. There we go. This is going to be equal to what? X times y, the two radicals. That's because we have the same index. And that all this is possible if this x squared and y not squared to the nth are real, the nth power. And the last one that I have here is the quotient rule. And this one says that xy to the nth power. And again, this is possible if are real numbers. And are just real. And this one, that is the denominator, is not equal to 0. All right? So I have this so you guys can write it down. Hold on. Right here. Make it. There we go. So the question is, what does it mean to simplify a radical? So it says that a radical is in simplified form if the radical has no factor raised to a power that is greater or equal to the index. For example, this one. It's not simplified because the radical right here has a power of 4, which is what? Which is greater than 3, than the index. So a radical is in simplified form if what? If the radical has no factor raised to a power that is greater than or equal to the index. This is the other way. Okay? Now, second, there are no radicals in the denominator of a rational or radical expression. We have a radical here in the denominator, so it's not simplified. Now, number 3, the radical does not contain a fraction. This one contains a fraction. So it's not simplified because the radical is a fraction. Now, let's do the exercises. Let's do some examples. So we are going to simplify radicals. That's what we're going to be doing. We're going to be simplifying radicals. All right, so the first part, we're going to multiply it. So we're being given the square root of 5 times the square root of 7. That's what? That's 35. What am I doing? Applying the product rule. The same index, I can multiply the radicals. The radicands, sorry. Now, the next one. I have the fourth root of 125 times the fourth root of 5. So what do? This is going to be equal to 125 times 5, the square root. And what is 125 times 5? 625. What's the fourth root of 625? 5. Now, the next one. The third root of 5y times the root of 3x squared. All right, so I'm going to multiply, right? So it's going to be 5y times 3x squared. I have the same index, so I could multiply the radicands. So right here inside, what do I get? I get 15x squared and y to the third power, and we're gonna leave it like Number 4, 5 over m t over 2. Okay, I have the same index, so it's going to be 5t and 2m. And that's going to be my answer. Now, I do have some more here. Number 5, we're going to simplify it. We were multiplying, right? So now we're going to simplify it. And we have 36 over 49 square root. So I'm going to do square root of 36 and a square root of 49. This is 6 and 7. I'm applying the quotient rule. The next one, will be 125 over 8, and this is the third root, the cubic root. Okay, so the cubic root of 125 divided by the cubic root of 8. This is 5, and this is 2. All right, now let's do number 7. I have 5 to the 8th power, and this, yeah, so let's do the 4th root of 5 and the 4th root of 81 times x to the 8th power. The numerator is going to stay the same. The denominator, the 4th root of 81 is 3, because 3 times 3 is 9. 9 times 3 is 27, and 27 times 3 is 81. So we know it's going to be 3. What about this one? Remember what we said? X, 8. We said that this was going to be equal to what? 8 divided by 4. And what is 8 divided by 4? 2. Right? So this is x to the 2nd power. And the last one that I have here number 8 is z square root of z and 16. So that's going to be the square root of z divided by the square root of 16. This is going to stay the same, but this one is going to be 4. Right now, we are going to, we're going to simplify it. This says and we've been given this. the square root of 98. But what happens there? Now, what should we do? We need to rewrite 98 as the product of a square and some other other factor. So let's do that. 98 is not a square, meaning it's not a number there's not a number that I multiply by itself and I'm gonna get 98. Okay? So the question is, what should we do? We're going to rewrite 98 as what? As the product, meaning the multiplication of what? Of a square and some other factor. Okay? So now, here are the questions. Here comes more questions. What's the largest square that divides 98? Could that be, let me write down the question. What is the largest square that divides 98? And the answer is what? 49. So if I have, hold on, what did I do with my pencil? Okay. So it's going to be 49 equal to what? To 49 times 2. 49 times 2 is 98. So, and I know the square root of 49 is 7. The square root of 2. That's going to be my answer. We're gonna try another one. I have a few more that we can practice. So, let's do number 10. Cubic roots. That's going to be 27 times what? 27 times 2. And we know that the cubic root of 27 is 3. 3 times 3 is 9. 9 times 3 is 27. So that's going to be my answer. Now, if they give us, for example, this one, a square root of 55. Okay, there's not a square number. 55 is not a square number. And also, there's not a product of a square and another factor that will give me 55. So we're going to say that no square factor greater than 1. Than 1, okay? Now, 12. Fourth root of 240. 43. So that's going to be what? 81 times what? If I multiply 81 by 3, I get 243. That's 3. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. Okay? And that's going to be my answer. So let's keep doing more exercises. We have, let's do this one. Oops. So we have 13 says 36 n to the 7th power. We gotta find the square root. So we can divide this in square root of 36 n to the 6th power times the square root of n to the 1st. So this is the largest square that is smaller than 7 and the largest multiple of 2 that is smaller than 7. Meaning we know that 6 divided by 2 is going to be 3. So I know this is going to be equal to what? To 6n to the what? To the 3rd power times a square root of n. Let's do another one. This one, we have 32 p to the 4th q to the 7th. All right, so I need to the 3rd power, right? So it's going to be 32. Is 32, it has a 3rd power, a cubic root, a cube. Can I get that from 32? No. Can I get it from 8? Yes. So we're going to start. Whatever is left is going to go here. So 8 times what? Give me 32. 8 times 4, right? Now p needs to be p to the 3rd power to give me the cubic. And what do I have left? 1p here. All right. And now on this side, I can have q to the what? To the 6. 6 divided by 3 is 2. And 1q left on this side. Here's like kind of, let's say, the leftovers. So what do we have here? 2p q to the 2nd power. And this is going to stay the same because we cannot do anything with it. Look at this one. To the 4th power, right? So we know 2 times 2 times 4 times 2 is 8 and times 2 is 16. All right. So 16 is going to stay here. Now, this one. The x is going to have to be what? Divided by 4. That would be 12, right? If I have 12 and I divide it by 4, I get 3. So the other one is going to be, what is the rest? 3. The fourth root of 16 is 4. 12 divided by 4 is 3. And this one is going to stay exactly the same. Okay? Now, so we could do 80 divided by 5. What is 80 divided by 5? 16. What's the square root of 16? 4. So we went the other way around, right? Instead of coming from here to this way, we did it this way. Okay? And I do have another one. Okay, 17. So I have to the 5th power, and I have a 3 here too. 64 x to the 9 and y to the 8. And I have here is the 5th root, x to -1 and y to the 2nd. So I'm going to do exactly what I did on this one. The 3 is outside, don't forget that. And this is to the 5th power. So I have 64. X is going to be the reciprocal, right? So if it's the reciprocal, we're going to add it up here. 8 minus 2, meaning this is what we have. Do it that way, okay? So what do I get from here? 64 x to the 10th power and 8 minus 2, 6. Okay? And I'm multiplying by 3, all of this. So my answer is going to be 3. I'm going to have 1 here and 1 here, 5th power and 5th power. 64. We know the 5th. If we have 32, we could get this the cubic, the 5th root of 32. And 32 times 2 will give us 64. Now 10 can stay here because 10 divided by 5 is 2. And the y, how many y's do I leave here? 5 and just 1 on this side. That's the leftover, okay? So what I'm going to have here is 3 times what? The 5th root of 32 is 2. 10 divided by 5 is 2. 5 divided by 5 is 1. And this is going to be multiplied to y. So my answer is going to be, I just have to multiply 3 times 2, x squared, y, 2y. Okay? For example, looking at what can I simplify from the next one. Okay. This one that I'm going to do is part of your homework. It's in your turn, so let me just do it. It's a very long one. Oh, we can try this one. Z13 and Z19. And we want the square root of these numbers. So first, what do I do with this, finding the numbers? Okay, 249, 294, sorry. I like to do the tree method. So divided by 2 is what? 147. Divided by 3 is 49. And divided by 7 is 7. Notice that the numbers that I circled because they're prime numbers. So what I have here is 2 times 3 times 7 times 7. So right here, I found the number 49 times 6. That's giving me the square. So let's do it. Here is going to be, always going to have 2. So the 294 is going to be divided in 49 and 6. The u, it needs to be what? To the 12 and just 1 u, because 12 divided by 2 is 6. Z is going to be 18, because 18 divided by 2 is 9. And I'm going to have just 1 left. So this is 7 to the 6 and Z to the 9. Okay, and that's my answer. You guys can do that to find the two numbers. For example, the one that we did 64. 64 divided by 2 is 32, right? 32 divided by 2 is 16. Yep. 16 divided by 2 is 8. 8 by 2 is 4. And 4 by 2 is 2. And we were doing to the fifth power, the fifth root. All right. So how many do we have? 1, 2, 3, 4, 5, 6. So we have 2 to the 6th power. So we need this one and this one. And 2 to the 5th power was 32. So that's why we divided 32 and 2. Now, let's do this one and list the numbers that you guys. This one we have 348 n to the 3rd power, n to the 9th, 147 n to the 2nd, and n to the 11th power. And we're getting the square root. All right. And if I divide, so let's get this 2. There we go. So 348 divided by 2 is 174. Divided by 2, 87. divided by 3 would be 29. So we have a 2 times 2, a 3, and a 29, right? And for the other one, we have 147 divided by 3 is what? 49. And 49 is 7 times 7. So let's transfer that over here. So we know that this one 3 times 4 times 29. 3, here it is. This is 4. Okay? And this one is 3 times 7, which is 49. All right? Don't forget that we have the n to the third, n to the 9, n to the second, and n 11 power. Okay? So right here, we're making a 1, right? Now, let's keep going here. So we have 4 at 29, 3 minus 2 is 1, right? And we write down the 49 down here. And 9 minus 11, so 2 are going to be on the bottom. Okay? So let's do the square root. So we're going to have 2, we're going to have 4 here, 49, and n to the second. On this side, it's going to be 29n. So square root of 4 is 2. Square root of 49 is 7. Square root of n squared is n times 29n. Okay? And I believe for some reason in Newton, this have to be absolute value because it's coming from an even index. All right?